All right, in this video, we're going to try to do the Unit 1 operation practice test together. It's focused on the understanding and solving, as well as the communicating and representing curricular competencies. First question, prime factorize 240. In order to prime factorize a number, we want to use a factor tree. So starting with 240, let's divide it by the smallest prime number, 2. Well, 240 is divisible by 2, so let's divide 240 by 2. I get 2 and 120. Let's divide 120 by the smallest prime number once again. 2 is divisible, so it becomes 2 and 60. 60 also divided by the smallest prime number 2. And 30 also divisible by the smallest prime number 2. Now 15 is not divisible by 2, so now let's move on to the next smallest prime number, which is 3. So I get the answer like that. And 5 is a prime number itself, so I've completely prime factorized 240. The result is 2 times 2 times 2 times 2 times 3 times 5, which is equivalent to 2 to the power of 4 times 3 times 5. Find the GCF and LCM of 240 and 225. So in order to find the GCF and LCM, we need to use a table. Let's divide both numbers by the smallest prime number possible. Well, 2 is the smallest prime number, but 225 is not divisible by 2. So let's skip 2. And the next one is going to be 3. Both numbers are divisible by 3. So let's do 240 divided by 3, which is 80. And 225 divided by 3, which is 75. And then let's divide this number by the smallest prime number possible. Well, both numbers are not divisible. 80 is divisible by 2, but 75 is not. 75 is divisible by 3, but 80 is not divisible by 3. So the next one has to be 5. 80 divided by 5 is going to be 16. 75 divided by 5 is going to be 15. And there's no more prime numbers that are divisible by both of these numbers. So we have completely, we're done with this table now. The GCF is going to be 3 times 5, multiplying the left two numbers is 15. And the LCM is going to be the 3 times 5 times 16 times 15. And of course, let's use a calculator to do this kind of thing. It's 3 times 5 times 16 times 15 is going to be 3,600. Next number. Next question. Use area model to multiply and simplify. So area model means that we're going to represent a rectangular model like this. We're going to divide into 4 sections because we have a binomial times a binomial. Of an x plus 3, so that means I can represent the first row to be x and the second row to be positive 3. And then the 2 columns are going to be x and positive 2. Now I need to find the area of each part. X times x is x squared, x times 2 is 2x, 3 times x is 3x, 3 times 2 is 6. So finding the sum of the areas here, x squared plus 2x plus 3x plus 6 is going to be x squared plus 5x plus 6. Part B, 2x minus 3 times x plus 5. Exactly the same thing. Divide the section into 4 parts. 2x here, minus 3 here, x here, plus 5 here. Let's find the area of each side. 2x times x is 2x squared. 2x times 5 is 10x. Negative 3 times x is negative 3x. Negative 3 times 5 is negative 15. 2x squared plus 10x minus 3x minus 15 is going to be 2x squared plus 7x minus 15 is my final answer. Now let's do question number 3. Factor x squared minus 9. So x squared minus 9 is difference of square shape, right? Because we know that x squared is a perfect square, 9 is also a perfect square, and it's binomial, and they're subtracted from each other. So immediately, using the factor form x squared minus b squared is equal to a minus b times a plus b, I can immediately conclude that it's going to be x minus, let's write this x squared minus 9 as x squared minus 3 squared. So it's going to be x minus 3 times x plus 3. Part B, 3x squared minus 48. Well, I think before we do anything, we need to find the greatest common factor of 3x squared and 48. In my opinion, the greatest common factor of 3x squared and 48 is going to be 3. So let's factor out of 3. And then I realized that 16 can be written as 4 squared. In other words, it's going to be 3 times x minus 4 times x plus 4 is my final answer. Next question. Factor trinomials. So in order to factor trinomials, in my opinion, the easiest way is to find two numbers that add up to the last number, negative 36, and also, to multiply to the negative 36, and find two numbers that add up to the middle coefficient, negative 9. So how are two numbers multiplied to negative 36? There's going to be a bunch of them, but it's going to be either 1, negative 36, negative 1, 36, 2, negative 18, negative 2, 18, 3, negative 12, negative 3, positive 12, 4, negative 9, negative 4, 9, and I think that's it. And let's find the sum of each cases. This is going to be equal to negative 35. This one's going to be positive 35. This is negative 16. This is a positive 16. This is negative 9. This is positive 9. This is negative 5. This is positive 5. And which one adds up to negative 9? This one, 3 and negative 12. So therefore, my answer is x plus 3 times x minus 12. It was positive 3 and negative 12, so it's x plus 3 and x minus 12. Is my final answer. Part B, similar thing, but before we do any factoring, let's factor out the greatest common factor. Well, for negative 2x squared, negative 8x, and negative 6, I think the greatest common factor could be negative 2. A rule of thumb is that if you see any negative coefficients on the x squared, make sure you factor out the negative side. So it's going to be negative 2 times x squared. Negative 8x divided by negative 2 is going to be plus 4x. Negative 6 divided by negative 2 is going to be plus 3. So therefore, two numbers that multiply to a times b is 3, and a plus b is 4. Well, it could be 1, 3, or negative 1, negative 3. That's it. And the sum is going to be like that. So that's the 1, 3. So therefore, my final answer is negative 2 times x plus 1, x plus 3. That is my final answer. Question 5. For the following diagram, find the tangent ratio of the angle B and the cosine ratio of the angle C. So first of all, to find the tangent ratio, we need to find the opposite and the adjacent. Using the SOHCAHTOA mnemonic, it means that sine theta is equal to opposite over hypotenuse, cosine theta is adjacent over hypotenuse, and tangent theta is equal to opposite over adjacent. So that means that for the angle B, the opposite side is going to be the 15 centimeters, and the adjacent side is going to be the 8 centimeters. For the angle B, at least. So therefore, the tangent of B is equal to opposite over adjacent, and tangent B here is going to be 15 over 8. And that's my final answer. Part B, find the cosine ratio of the angle C. So in terms of C, things are a bit different. Let's redraw the diagram one more time. Remember that the opposite and adjacent sides are dependent on the perspective. So it means that according to the angle C, the adjacent cosine is adjacent over hypotenuse, so adjacent side is going to be the 15 centimeters one, and the hypotenuse is this side, which is unknown. So I think in order to find the hypotenuse, we need to use a Pythagorean theorem. Pythagorean theorem goes like a squared plus b squared equals c squared, 8 squared plus 15 squared equals c squared, 64 plus 225 is equal to that. Sorry, not 225. It is 225, my bad. And then I add them together. It's going to be 289 equals c squared. And if I do a square root of that using calculator, I get c equals 17. That's 17 centimeters here. So therefore, I know that cosine c is going to be adjacent over hypotenuse. That means cosine of c is equal to adjacent, which is 15, hypotenuse, which is 17. And that's my answer. All right, thank you for following along the video, and good luck on your unit test.